All right, now let's take a look at a Bernoulli equation first order ODE. I like these because they mix up change of variables, so they use change of variables along with integrating factors. So it's a great practice overall. So the form of a Bernoulli ODE is like so. dy dx plus capital P, so it doesn't confuse you, P of x times y equals q of x times y to the n. So we want to make this equation right here look like such. To start off, we want dy dx by itself. So it makes sense to first divide by x all throughout. So let's do that. We have dy dx and then plus, let's write it as 1 over x times y, and then divide by x over here. We will get 1 over x, and I want to go ahead to write 1 over y squared as y to the negative 2. That way it's much easier to see what's going on. So now it makes sense. We can clearly see that it's in the same form. We will have p of x as 1 over x, and then right here q of x is also the same thing. And then we would have n equals negative 2. So the way Bernoulli equation works is it introduces a change of variable. We will say v equals y to the 1 minus n. This is the rule. Therefore, in this situation, 1 minus negative 2 is just 1 plus 2, which is 3. So we get v equals y cubed. Okay. We also want to find dv dx. So to get to dv dx, we first must do dv dy and then dy dx. Since v is not a function of x, but y is a function of x, so we're using chain rule. Well, we can get dv dy since we have v equals y cubed. So basically we're going to do that. It's going to be 3y squared times dy dx. All right. Now we would like to put it back into this equation right here. Well, I want you to first write dv dx out. We're going to say 3y squared dy dx. If we want to make this equation the same while keeping this in here, we need to multiply every term by this piece up front so that it can equal the same thing. So first we're going to have 3y squared dy dx plus, then we're going to have 3y squared times this. So I'm going to say 3y squared over x times y equals 3y squared over x times y to the negative 2. All right. This is basically the same equation as the one up here. We just multiplied everything by 3y squared. But notice how we can just say this piece right here is just dv dx. That was the whole goal. So we got dv dx here. And then let's add 3y squared times y is just 3y cubed over x equals 3y squared times y to the negative 2. These two powers cancel, so we just get 3 over x. That just turns into 1. Okay. Y cubed is actually just v. So this actually turns into dv dx plus, and we're going to take out the y cubed, we're going to say 3 over x times v equals 3 over x. Wonderful. This is the part of the equation where we apply integrating factor. So we know integrating factor is just p, small p of x equals e to the integral of a1 of x dx. In this case, we can see a1 of x is right here. Okay, So this equals e to the integral of 3 over x dx. And that's simply just e to the 3 ln of x. And by using log rules, we can say that this equals x cubed. In the rules of integrating factors, you go back and you multiply everything by that. So we get x cubed dv dx plus, and x cubed divided by x is so simple, we're just going to get 3 times x squared. 3x squared and then v. See how we did that? We still have the v, we have the 3, and then x cubed divided by x is just x squared. We should get 3x squared. All right, switch back to this color. Now this is just a chain rule right here. It will be d dx. We will have the v, since that's a constant right here, and then times whatever is left out here, so vx cubed. And we can recheck it. If you hold x cubed constant, we get dv dx times x cubed. That's right here. If we hold the v constant, we get the derivative of x cubed times v. So we have v here, and the derivative of x cubed is 3x squared. Perfect. And then that equals 3x squared. All right. So now we can integrate both sides, and we end up getting vx cubed equals the integral of 3x squared dx, which just equals 3x cubed over 3, which is just x cubed. And do not forget the plus c. That is important in this last step. Right there. We also know v is just y cubed, as previously said. V is just y cubed. And we want everything in terms of y and x. We end up getting y cubed, x cubed equals x cubed plus c. We can go in and divide everything by x cubed. We end up getting y cubed equals x cubed over x cubed is just 1 plus c over x cubed. You can write it like this, or you can take the cube root, but this would be your final answer.